Hi folks, welcome back to my second lecture on the SQL Select statement. In this lecture I want to focus on how to sort data as well as how to selectively pull data out. So let's go ahead and jump into this. Let's take a look at how we sort data. Sorting data, or what we call ordering data in SQL, is used by the order by clause. And the order by clause for now is going to be the last thing that we have within our select statement. So you'll take a look at this example that I have on a slide here. It says select last name, first name from members, which we should be used to now. That's pulling the two columns, the name last column and the name first column out. And it's using them as the default column names. But now what I'd like it to have done is I want it to sort the data. So the order by clause, it's two words, order by, is used to sort by default ascending, which means that in this case all the last names are going to be sorted first, and then after that all the common last names or the same last names, like Jones for example, would then be resorted by first name. Now the default on this is ascending. But if I want to turn the sort around a little bit, I can use descending, which is the DESC key word. Ascending is not required, but descending is. So let's just take a look at a couple of examples of this. So I've already logged into my SQL Server. Let's go back in and let's take a look at the weather table here. Actually, let's look at the baseball table initially. It's going to be an easier table to sort on here. So we'll open up baseball. And let's take a look at the tables, and let's focus on the players table here. Okay, so pull the columns open, and I'm going to go ahead and open up a query here. So with baseball selected, one of the methods is a new query. It should then open up the query window and allow me to work directly on baseball. If it didn't, then I'd go back up here and I would select a different database, or I would use the use statement over here, and I could say use whatever table I want to use. But we're going to focus on baseball 2015 now, and we're going to focus on players. So let's take a look at the basic statement here. Select star from players. Now by default, when I run this, it's going to come out in the order of the primary key. Now by default, the data is going to be ordered in the table, as far as we're concerned, in the primary key order. We refer to that, by the way, as a clustered index, which means that the data, as it's written to the table, again, as far as we're concerned, is in the order of the index. So I'd expect this data by default to come back in player ID order. So as I add different player IDs in here, it's going to change the order. But let's take a look at it. So right now, everything should be sorted top to bottom, as you see over here in the left-hand column, by player ID. So again, that's the default. But if I want to change that sort order, let's make this a little bit more readable here. So let's pull out name first and name last, weight and height. So let's do name first, name last, weight, and height. Okay, from players. Do I have everything right? Let's check it. It says the format's okay, let's execute it. So now I'm just pulling up those basic columns, and notice here that it just so happens that when Lehman, the fellow that built this database and table, put the data in, he started putting the data in last name sequence anyway. Okay, so let's go back and take a look at this. What I want to do right now is let's put all the data in first name order. Not sure why I'd want to do that other than demonstration purposes, but nonetheless we can do that. So I'm going to do an order by, and then the column that I want to order by, in this case it's name first. Now I'm going to find out that I have an issue probably with name first, and that is that there's been a whole bunch of baseball players in the early days that played baseball. We knew what their last name was, but we didn't know what their first name was. Let's take a look at this. So when I run this, all the data comes back, but notice now that I have a no for the first name. I have a last name, I have no weight and no height. These are early baseball players that we didn't maintain that information on, but if you look down the table here, so let's drag down the table, you'll see that all of a sudden, the more current players, the data starts appearing in here. Okay. Now, and also notice that the order that the data exists, the nulls sorted first. Now, as I pointed out in the past, Null is the absence of data. It means that we never knew what that first name was, so we're not going to put anything in. We could have put an empty string in there. An empty string basically would have been, apply a quote to it, or just go back in there and put a space into it. We didn't want to do that. We wanted to make sure that if we didn't know what the first name was, or the weight, or the height, we left it as null. Later, that's going to be important, because null data is not going to, it's going to sort, but null data, when it comes back, will in aggregate functions will not total. So if I came back and said, what's the average weight of all players that have played baseball, it's not going to treat a null as a 0. It's just going to ignore it entirely. That's another lecture down the road here. But understand right now that the nulls sorted first. Had there been empty strings, they would have sorted after the nulls, and they would have just showed empty within these columns over here. Wouldn't have the word null. Okay. So now I'm going to order by first name, which I did, and everything's coming out in first name order. I would expect at the bottom of the table to see names with Z's in it. So by default, we sort ascending, top to bottom. Okay, and I could, if I wanted to, put the ASC here for ascending, but that's implied. Don't have to do that. But if I do want to sort backwards, okay, then I would do DESC as the keyword after that, and then I execute it. And now you'll notice that the names are coming backwards. Okay. First name, the last names weren't sorted at all, but the first names were. Now, if I wanted to make a recall list, so I could look down and find a person's last name and then immediately find their first name, probably what I'd like to do is sort by two different columns. So I would sort by name last, then I would subsort by name first. So what's going to end up happening is all the common last names will sort. And then anybody who, all the last names will sort. Any common last name, for example, looking down the list here, we've got 2 Zebs in here. Okay, and these are not in alphabetical order. Notice the T comes after E. So by me doing it this way, I'm telling it first sort by last name, then subsort by the first name. And it's going to be ascending automatically. So let's run this. And you'll see down the line that David Ardzema, 2 A's in it, Hank Aaron, they all sorted. And then right down in here, you'll see there's a whole bunch of different Abbotts. So let's highlight these. Okay, in fact, I could do it this way. Highlight the Abbotts all the way down to here. You'll notice now that the first name sorted alphabetically as well. And that's what we get out of the default sort. Now, if I wanted to, I could sort both of these descending. If I wanted the list to come back opposite, I could do this. DESC, DESC, and when I execute that, now I'm going to get a total backward search. I'm getting the Zeich, and there's only one, which is Tony. But if we get down here a little bit further, here's 2 Zubers, and notice that the B sorted after the J, which meant the whole thing sorted backwards. So let's jump back to the PowerPoint slides. I might have got a little bit ahead of myself here. Let's just take a look. So we understand now that the order by clause is used to sort the data. We start sorting by the columns that are listed here. So we're ordering by name last, by name first. And then also notice then down here at the bottom I show you how we can use descending. And we could use descending on one and not the other. For example, going back to my example here, I could have sorted the last name in the regular order, but the first name descending. And what I end up with now is all these Abbotts now in here are sorted, but the first name now is descending. So we have our choice. See how last name, first name now goes from D all the way up. And I see I included Abby here. Shouldn't have done that. Let's go all the way down to this point. So what it's telling me now is these are sorted backwards. D, E, F, G, J, J, K, and O, P. So just an example. Let's jump back. Now we can also order by column order if we want numerically. So if I came back in and said select name last, comma name first from from members, order by 1, 2, I'm telling it now to order by the first column, then by the second column. And I can also after this use descending. Now, the challenge with this is going to be that when we sort our data, if we ever come back and we add something into it like this. So now let's say I've changed this select statement, I've now added the middle initial in on this bottom example, my sort's messed up. because now what's happening is it's sorting by last name and by middle name. Had I used this previous example that we had here, okay, by column name, it wouldn't have made a difference. I don't recommend you use numeric ordering only because these select statements tend to change as time goes on, and anytime you change it here, you'll always have to remember to go back in and change the order over here like we did down below. Whereas if you use the column names, you don't have to worry about that. Now before I go on, I want to jump back and show you one thing that I failed to cover over here in the order by. So now what I'd like to do is let's get rid of this weight here. And what I want to do is I want to come back in here and have height as feet. So this is that calculated column we talked about earlier. So I'm going to divide this by 12.0. Remember I had to put the 0.0 in there in order, let's look at the data here. I had to put the 0 in here in order to get my answer back with decimals on it. That introduced that decimal to the formula, which gave me an answer back as decimal. Again, remember, if I had not done that, then it would have been an integer divided by an integer, and I would have only had the rounded height here, which I don't want. Okay, so let's go back and correct that. Now I have to go back and also give it a column header. Any calculated column has to have a column header. I could use the same column header that I originally had in the formula. This is how the data is going to return. So if I wanted to, I could still call this height again. Now, again, don't confuse this height that's being returned to the program that made the call the same as the height column. Remember, as I told you before, that once this data hits the computer that generated it, maybe a C# program or a Ruby program, it has no clue that the new height is not real, that it's calculated. It doesn't care at that point. All it cares is it received data. Now, let's go ahead and take a look at this. Let's execute it. Okay, so I'm getting the answer back correctly, but now what I'd like to do is I want to sort or order by the height. I want the tallest height first, so I'm going to get rid of this. And there's two different ways we can do this, and I want to explain this carefully. When we run this select statement right here, the very first thing happens is it goes out and grabs that data and brings it back into memory. The next thing it does is it orders that data once that data is brought back into memory. So that opens the door up for a little bit of opportunity. First of all, if I want to order, I can order by the formula. So if I take this formula right here out and I say I want you to sort, let's try that again, make that correction. So what I want is I want it to order by the height divided by the 12. So basically what this is going to give me is an ascending size. Let's run this and take a look at what's going to happen here. So notice now that because I have a whole bunch of players that didn't have height at all, if I look down the row here, null sorted first, and then down below here somewhere, there we go, I now start getting the height of the players. And there is Eddie Goodell, the shortest player that played, and then we've got Bill Finley, who, let's widen this out, Bill Finley, who was about 5 1/4 feet tall. Now, what I'm showing you is I can sort by that calculated column. That is the column, so I can sort by that. That is the column, I could sort by that. But there is an added feature for the order by. Since this data right here is run first, and then it goes back and orders, what I can also do is I can now order by the column header that is created for that formula. So I could come back here and say I want to order by height here and execute it. Now again, what it's doing is it's not ordering it by the original column height, it's ordering it by the height column that it sees over here. In this particular case, it doesn't really matter. Let me show you and I'll prove that. So let's run it, and I'm getting it height smallest just like I did before. Let's do a descending on here. So I get the tallest first. Okay, so the tallest player played was John Roush. He was pretty close to 7 feet tall. Okay, now let's go back and prove now that this is the case. Let's call this new height, and just simply come down here and say new height. Okay, and execute it. Again, the reason it's letting me do this is because it runs this statement first, then it's going to order the data. Now we're going to come back later and talk a little bit more about power use of this order by clause, but I think right now let's jump back to the PowerPoint slides and jump into the where clause in just a second here. Before we do that, let's talk a little bit about the top command. I'm going to show you this command right now, but I'm going to tell you here in about a week or two, I'm going to tell you to stop using it. It has a place, but not for the particular use that we're using right now. So what I can do, pardon me, is I can say I want to strip the top 10 players off the list. I mean, if I go back here, let's just take a look at what the top does. So let's get rid of this order by clause for right now. In fact, I think what I'm going to do is just move it down a little bit, and we're going to ignore it. And the way I can ignore it is just highlight this statement, and just that statement alone will run. So if I just simply want the top 10 players, okay, I can just simply say top 10, and all it does is it just gives me the top 10 that would exist in the entire list. So by highlighting this by itself, it will ignore the order by, and I only get the top 10 right here. See how that worked out? But this is the top 10 in default order, just the order they were entered in the record or the primary key order. So let's change this around a little bit. Let's say that I want the top 10 tallest players. Okay, I can use top 10 in this case, and watch this. Now what it's done is it's done the order by, and then it's just simply pulled the top 10 of that order by, so I can see these are listed as the top 10 players. But there's a problem with that, and that is generally you assume that when you have the 10th player here, if there is a tie, meaning let's say that there's 3 or 4 players that were 6.75. In fact, look at all these guys right here. Okay, the challenge is it's not going to tell me that perhaps 11 through 22 are also 6.75. It's just grabbing the top 10. Later, I will show you how to go back in there and say, look, give me the top 10, but if there's a tie at the top 10, give me all the ties that match as well. So that is a weakness in the top 10. Now, is there a bottom command? Notice how I've got top 10 here. There is no bottom command that exists, folks, but if you think outside the box a little bit, you don't need it. Because if I want the shortest players, the bottom shortest players, and of course the problem here is I'm going to get nulls, but all I would have to do then is change the sort order. Right now I'm sorting largest to smallest. If I want the smallest, let's just take the descending out here, and now this is the equivalent of the bottom. Even though I'm still getting nulls out here, these tend of course at this point to be the bottom 10. We're going to come back and play with this. For now, stick with it. But later, read my instructions very carefully, because I'm going to tell you later in an assignment you cannot use the top statement here. I want you to produce the output without the top statement. For now, it works really well, and it does give us a good idea, but it's not very precise. Okay, this again talks, the slide talks a little bit about the weakness in the top, and what if there are identical matches? How do you deal with it? We'll come back to that one a little bit later when we start talking about aggregate functions. Now let's start getting into some power use. So far we're pulling out every record, or we're only pulling out the top 10 or top 15 records. But what if we want only certain records returned? In this case, what I'm telling it is I want the top 20 players returned back, and there should probably be an order clause in here, but where the weight is greater than 200 pounds. So now what we're going to use is a where clause, and the where clause is used to selectively pull records out. Only give me those that weigh greater than 200 pounds. Only give me those players that were born in Seattle. Only give me those players that were born in Portland, Oregon. Those are the kind of things that we can pull out. In fact, that's just the tip of the iceberg. We have operators that go in here first. So we have this greater than symbol, which is standard. We also can use the equal. Give me all those players that had exactly 200 pounds, or as we just did, greater than 200 pounds, or less than 200 pounds, or less than equal to 200 pounds, greater than, and then we have several that are equivalent to what's called not equal to. Give me those that are not equal to 200 pounds. Anybody, I would get everybody except those people that were exactly 200 pounds. This is also the equivalent to not equal to, and then I can use the keyword not. And we're going to come back and visit those. I also, going back to our introduction of programming days, have the ability to use ands and ors. Now you'll recall that in C#, an and is an ampersand ampersand, and an or is that bar bar. But in the SQL world, we actually use the ands and the or statements. Now, before I go on, I'm going to come back in and show you demonstrations here. The rules that we're going to find in data types match the same kind of rules that we typically find in programming like C#. So in this case, if name last is a char column, a character column or a string column if you will, then if we're looking for values in the name last column, we have to put apostrophes around it. So in this case, I'm looking for the people that have the last name of Jones, and I have to put apostrophes around it. If I fail to put apostrophes around it, it's going to come back and think that Jones is a column. It's going to come back and think I'm asking where the name last column equals the Jones column. That's not at all what I want. So string literals are going to have apostrophes around them. We're also going to find out that dates will also have apostrophes around them. They'll be treated the same way. So if this was a date column, then I would have to put my date in with an apostrophe, and I could use a variety of different formats. I could actually type out January 1st, 2017 if I wanted to, or I can type out Jan 1, 2017, or 1/27/2017. There's a variety of different formats, but I need to put apostrophes around dates, as we'll take a look at soon. If we're dealing with numbers, a numeric column, like this would be a real column or an integer column, probably an integer in this case, then I do not put apostrophes around the data here. I do not do it. It'd be the same way if we were dealing with C#. You only put apostrophes around strings, but let me tell you, there is an error correction and detection built into Microsoft's version of SQL that if I was to put apostrophes around this, it would let it work. I hate that fact. I wish it would fail, but it would let it work. So before we go on, let's jump back. We'll come back and take a look at some of these others, but let's see what we've got so far. So I'm going to jump back over to my SQL. Let's get rid of the order by. And by the way, in the picture of things, the where statement will go between the select and the order by. Okay? But we're going to get rid of the order by and just focus on the where clause right now. So right now, let's get rid of the top as well. And I'm going to go back in here and I'm going to add a couple things in here. I want birth city and I want birth state. Okay, now I'm going to run that just to make sure I got the right format. Yes, I do. So I'm ending up with the city and I'm ending up with the state. Now I'm going to do a where clause here. And what I'd like to do is I want to find all those people that played baseball that were born within the state of Washington. Okay, so I'm going to say where birth state equals and then WA right here. Okay, I'm going to check it to make sure the format's right. It is. I'm going to execute it. And now notice that all I'm getting back right now are players that were from the state of Washington only. Now, what if I want to get players that were from Spokane? Okay, now you want to be, I'm going to show you this, you want to be very careful on this. Let's come back here and let's say where birth city equals Spokane. Okay, so I'm going to execute this guy, check it, execute it, and it comes back and tells me that there's 10 players that were born in Spokane, Washington. And actually, that's not the case. This is where the error may come in. It's telling me that there's 10 players that were born in Spokane. It just so happens by looking over here that there's only Spokane, Washington entered into this table. There happens to be other Spokanes in the rest of the nation, communities, not cities. But let me make this a little bit more impactful here. Let's use Portland. Okay, so when I run Portland now, I'm going to get people that were born in Portland, Oregon, as well as Portland, Maine. So it's very easy to misread your data. It's very easy. You need to understand your data carefully to make sure you're pulling the right information out. In this case, Portland wasn't good enough. If I wanted Portland, Oregon, I'd have to use the AND clause. And I'd say AND birth city is equal to Oregon. Now in this particular case, it's going to strip out. So I've got right now, if you look in the bottom right hand corner here, 78 rows that were returned from Portland. If I now nail down Oregon and I execute it, oops. I see I made a major mistake here. Notice I'm looking for burst city is Portland and burst city is Oregon. We're going to come back and talk about this mistake later, but really what I meant was burst state here. And what it was looking for before, by the way, folks, is, which is impossible. It's saying, I want all the people that have Portland in their burst city, and in a previous example, I want all those people that also had Oregon in their burst city. It's impossible. You can only have one thing in burst city. So let's go ahead and run this and see what we end up with. So we lost 20. We had 78, I think, before. Now we've lost 20, and notice everything here is Portland, Oregon. Portland, Oregon. Okay. And if I want, based on this, I can look in the bottom right-hand corner to, again, see how many records were returned. Now later, if I want to write a select statement that specifically tells me how many people were born in Portland, Oregon, I'll have to write the statement up here and have it return the number here. Why? Because the computer can't look at this bottom right-hand corner like we can. So let's go back and take a look at another column here. So I'm going to go ahead and take out the column list here, and let's put an asterisk in. And what I'd like to do now is I want to know all those people that had a weight of greater than 200 pounds. So let's do weight greater than, oops, let me try that again. Weight greater than 200 pounds in all my players. So now I've got all the columns coming back. Let's execute it. And you'll see if I look over here, I've got, here's my weight column, and everything in here there should be no 200. Now this is exclusive 200, not inclusive, which means I'm not going to have any, if I want to include 200, I have to say greater than and equal to 200. Oops, equal to. Now if I run it, oops. Now, good example here. Why did I get the error? Because remember I told you if you highlight the whole statement, whatever's highlighted runs. Since I erroneously just highlighted the equal sign here, it just tried to run the equal as the entire statement. I either highlight nothing and run it, or I highlight the whole statement and run it. And now if I look over here, I'm now getting players that had a weight of 200 pounds, which I didn't have before. So the challenge that I have with it is, this is the proper way to do it, the way we have it right here. If I put apostrophes around this, technically this should not work. This is a numeric column with a string, but as you're going to find out, error correction detection will allow it to work. It shouldn't. If you turn something like this into me, I will not take points off, but I'm going to try every time to point out and say that's the incorrect method. You want to stick with the clean way, what we call the white hat ways of doing things. The white hat ways means follow the rules, because as the rules change, you may have issues down the road if you don't follow the rules. And the other reason is I can't tell you whether Oracle or DB2 or those other major databases, I can't tell you whether or not they'll allow apostrophes around. I know that this is the ANSI SQL method right here of getting it done. So now let's go back in and take a look at dates here. I want to look at dates and how we deal with it. So what I want to know is I want a list of all the players that were born before 1900. Okay, so what I'm going to do here is if I take a look, I've got a column here called dBirth. Where's it at here? Oh, it's called birth date. So I've got birth date in here. So I want to know all those here with a birth date, okay, of less than, and I'm going to do less than, and then in here I will do 1900. I want all those players, notice apostrophes here, I want all those players born before January 1st, 1900. So it's going to give me all the players born within the 1800s. Okay, let's execute that. And notice now for date of birth, where are we at here? All of my date of births now are 1800s or prior. Now, let me try something out. I think, let's see if it'll let me just put a year in here. Let's try that. And in this particular case, it let me even just get away with just putting the year in. I would suggest that you probably don't want to use the year. I would suggest you probably want to use the entire date, January 1st, 1900, but nonetheless, you saw that that did work. Okay, and let's see, what was the other thing that I needed to explain here? We've got the where clause. Let's go back in and talk about how we deal with those nulls. Now, if I wanted to know how many players had an empty string name, I could say where something like name last is equal to apostrophe, apostrophe, nothing in between it. That's going to look for an empty string in it. That means generally that there was data before, it was deleted out, or somebody went in there and on purpose said, I don't want this to be a null data. And if I run this, I don't believe I'm going to get anybody back. So there is nobody out there that has a name last that is not filled in. Let's try name first, just to make sure, because that's where the nulls were. Okay, I want those where they're equal to null. Notice that there's none of them in there, but I do know I have a whole bunch of nulls. Nulls are a different beast. Normally, if we're dealing with strings or numbers, we're going to use a format like this. But it's important to understand that when we're dealing with nulls, the key word that I would deal with in null is I'm testing for a state. Now, I'm not going to test to say, is the null the value, because null is not a value. I want to say, is this column a null? And the way I do that is where name last is null. I use that keyword and I say is null. So I'm asking it, give me everybody back now who has a null in that first name. I execute it, and boy, you're going to see, because I have all columns coming up, that the early baseball players, there was a lot of data that was missing on those early baseball players. But notice now that I'm getting them where all the first name is null. Now before, when I ran this data, right here, so I'm just highlighting that top column here, and I ran it. Let's go back and take a look at that first name here. So here's my first name column, and if I look down the list here, embedded in here with those players, there's going to be nulls in here, and I can prove that by when we ran this out. I know that there's some in there, that's showing it to me, but there's so many players coming through it. Now what I want to do is I want to eliminate those nulls. When I do this right here, I want it to return back all the players, but I only want players that have first name. Okay, so what I'm going to ask it for is where name first is not null. So you're going to have to play with this a little bit. We're going to come back, but this will then pull, it will give me all the names, but it's going to exclude those players. And if I look down the name list here, I'd find that there are no nulls in this list whatsoever. None. And I can prove that because now let's add another layer on this. Watch this. I'm going to do an order by, and now I'm going to do name first. Remember, it's automatically going to do ascending. This is that first example that we did a minute ago where all those null names came up. But now I'm telling it to exclude those null names. Let's execute it. And now, if you look down the list here, I have no nulls. Before I had all those nulls at the top when it ordered by. Let me prove that. Let's take this statement out. Let me Control exit. Let's highlight this, rerun it again. And again, notice how the nulls are at the top. But by me going back in and simply adding where name first is not null, it's excluded those out. Now, I could go back in also. Let me show you something else here. I can do where name last is equal to Jones. So I want all those people that have a last name of Jones that have played baseball. Now, by the way, this, because I'm asking only for Jones, obviously will not bring any nulls up because nulls don't equal Jones. So this is a way to eliminate all those nulls as well. But if I look down the list here, there's 97 players throughout history who've had a name of Jones, and here's my last name of Jones. Okay. And if I wanted to, I could say and name first equal, let's see if there's a Dave Jones out there. And there are no Dave Jones. Let's try David. No David Jones. So let's highlight this statement. What am I end up with here? These are all my first names, so let's look up Bill Jones. And execute it. Oh, again, notice I just had that apostrophe highlighted. Okay, there's my two different Bill Jones, and I want to point something else out too as long as I'm doing this. Watch this. Uppercase Bill, uppercase Bill, and it didn't make any difference. So why does it not make any difference in case? Originally, when the SQL Server was set up, there's a setting in SQL Server that tells it to ignore case, and normally we're going to want to ignore case. I will tell you though that as a database developer, one of the things that I always do is I normally won't let my data be entered in like this. I will force all my data to be uppercase. Now, when I read the data back, there's ways of forcing it back to upper and lowercase. For example, if a client of mine wanted to have a mail list created or a merge letter and they didn't want it to say Dear Dave Jones all uppercase, then there is a way that I can change that. I can grab the first character, make it upper, the rest of it lowercase. That's a programming feature. And another thing I do want to point out as well that I haven't talked about yet is notice how this data is coming back right here in this strange format. It's given me year, month, day, in this date, hours, minutes, seconds, milliseconds. I want to point out that that doesn't matter. And in fact, check this out. If I came back in here and I wanted to pull out, let's look at this here. So I want to do name last, name first, and I want to do height, and I want to divide that by 12.0, and I want to call it the new height command here. Let's check this out. Let's execute it. And now notice how the height is coming out in this long format. Probably my user doesn't want 6.250000. They're probably satisfied with the 6.25. But let me point this out. That's not your job as a database person. Your job as a database person is to return the raw data back to the programmer, and the programmer is going to use some kind of statement to go back in and format it the way he or she wants to. I showed you that earlier in Introduction to Programming where we have that toString method, and the toString method lets me go back in and set the format. I can make, as a programmer, the data look any way I want, but it's not the responsibility of the database person to go back in and format that data. It's their responsibility to create the data, to do the formulas, and also the programmer could do this on the other end. They could very easily grab the height, divide it by 12 on their end, but the fact is by me doing it on my end, my SQL Server runs about 1,000 times faster than it would take the C# program to do the same thing. So any of the formulas that I can do on my side, I'm going to do. And that's going to benefit the programmer. But I'm not going to worry about formatting data. If, for example, if the user wants a percent to come back, what I'm going to deliver to them is maybe something like 0.756643. It's their responsibility to convert that maybe to 75% or 75.6%, but it's not my responsibility as the database person. We just produce the raw data, let the programmer finish that off. Let's continue on and make sure I covered everything within my statement here. One of the things we need to talk about are the Boolean fields. And the Boolean fields, when we come back in and we have Boolean fields, they're going to produce a true or a false in our output. So let's go back in and see. I'm not sure if I have a Boolean field directly in here. Let's take a look here. So I don't have one there. Let's see if I've got one in weather. I might have to come back and demonstrate this one a little bit later. No Boolean field in here. So let's see what we've got here. Let's see if they're baseball. Do I have north wind still in here? I I do. Let's see if they've got some table. So this Northwind table is one you don't have access to now. If you want it, let me know. But this is that raw data that Microsoft uses when they teach SQL, and it's fake data. They got this fake company here. I chose baseball because it's meaningful data. But let's go back over here and see what we've got. Are there any? No, have any? I might not be able to demonstrate this one right off. I might have to come back to this one. So what I'm doing is I'm looking at the columns, and I'm looking for a Boolean field. Now what a Boolean field is in SQL is called a bit field, B-I-T, and what it does is it stores a 0 or a 1. But when you write your select statement on the screen, it's going to change that 0 to a false and the 1 to a true, but only for output purposes. For our purposes, we're going to always refer to it as a 1 or a 0, a 1 being true, a 0 being false. So in this example that I had on the slide here, and apparently I don't have a quick one I can show you, is there was a Boolean field set up in whatever this table members is. And there's a field called is senior. And we're going to store is senior. If they are a senior citizen, we put a 1 in there. If they're not a senior citizen, we put a 0 in. If I write a select statement and I say return this, is senior is either going to have the word true or false in my select statement output. But when I refer to it, when I want to grab the data out, I can't use true or false. I'm going to use a 1 or a 0 in order to pull that data back out. This is talking a little bit about the data types and dates. So it's showing you how I put apostrophes around a date. By the way, I can also go back in, and if I wanted to, I could put in square brackets. So a square bracket would be something like, let's go back in here, and I want the D, that's birth date. So I want the birth date in here, but I only want people that have birth dates, and I did this a minute ago where birth date is, let's do greater this time, greater than, and before I did 01, and we'll do greater than or equal to since I'm doing 1900. So I want all those people born in the 1900s. So 01/01/1900. So greater than or equal to 1900. And if I run this guy, I'm going to get the people that were born greater than or equal to. Let's change this. I could put square brackets in here if I wanted to as well. And it will do the same thing. Those are optional. And I believe the builders, let's see, is it still, it's going to be an error. Maybe it's not going to work here. Aha. It did not like the square brackets here. Wonder why that was. Let's try one more time. Apostrophes work. Maybe this is a new feature now in the latest SQL. They usually don't take things out like that, though. I might have to come back and play with that one just a little bit. I do want to point out, though, that if I didn't have these on here, the issue, and one of my slides will point that out as well. So what it's going to do here is it's going to say where the birth date, it's going to error out to begin with. But in actuality, it's going to say, look the birth date up, and I want the birth date that is greater than or equal to the number 1 divided by the number 1 divided by 1900. That's why we have to put, obviously, the apostrophes in here to make that work. Another thing too that I'd like to point out, and I had that in one of my examples, is let's pull out where name last equals, and I had Jones here. Okay, and if I execute that, I'm only going to get the Jones people back. But if I was to take these apostrophes out here and check it, notice the checking says it's fine. Why? Because the format's okay. What it thinks is right now that Jones is a column. Since there's no apostrophes around it, if I go back and execute it, it's going to say no column named Jones. So it's looking for where the last name column is equal to the Jones column. It's not what I want. I want the Jones value included. See how that goes? Now let's talk a little bit about the not statement, how we can deal with not. The not statement is just the inversion thereof. So if I have state equals California and I put not in front of it, it's going to give me it's going to be the exact opposite. It's going to give me everybody but the state of California. Or if I say where member equals 0, that's assuming that member probably is a Boolean field. It actually could be a numeric field as well. But probably in this case, this would be where member is false here. Or this is saying where, and both of these will say exactly the same thing, by the way, folks. This says where member is equal to false, and this says where member is not equal to true. So two different ways to write exactly the same statement. Which is the right way? Well, the right way is the one that's going to produce the correct output, and I would think that either one of these would be okay. Probably this top one reads a little bit better than the bottom one. Okay, but they both are going to produce the same information. And I could also use, instead of saying the not here, I could say member not equal to. So I could use the greater than, less than symbol right here should I chose to. Okay, and again, we've been talking about nulls and empties. And I just want to reiterate my concept of nulls and empty. Before we do that, let's jump back here and let's just take a look at this one, just where the not comes in. So in here, I'm asking, were all the names equal to Jones? If I want everybody but the Joneses, I could say where not name equals Jones. And when I run that, you're going to see every name pop up, but there's not going to be any Joneses that pop up. Or, I believe, I can do it this way as well, where the last name is not equal to Jones. Again, which one is the better one is the one that you remember and the one that you like the most, because they both work. And any employee of mine that wrote it either way, I'd be satisfied with that. Okay, so going back to null and empty, I just want to reiterate the difference between null and empty. Null is not a value. Empty is a value. In a string, empty means there was probably data before and there's not data now. So we're going to produce, it produces a problem. Nulls are going to be a pain for us out here because nulls are treated different than empties. So the example I like to use, and I use it in class, is null and empty are like having a bank account. If you went to Bank America and Bank America says you have an empty account, that means you have an account with Bank America, but you have no money in it. It's empty. Whereas if I go to Bank America and I say you have a null account, that means that Bank America doesn't even know who the heck you are. You don't exist whatsoever. You've never existed at Bank America. Now, we're going to find that nulls are going to produce problems for us as time goes on. And one of the biggest problems I want to demonstrate right now is in the form of concatenation. Okay, so right here, what I want to do is let's pull this out, and I want to produce a first name, a last name, and a middle initial. So if I come back here and I look at my data in baseball, and let's go to players, notice that, let's see, I have a, do I have a middle initial in here? I have a first name, I have a last name, I do not have a middle initial, but I do have a name given. So let's do that. Let's look at those. I'm going to take this out, and I'm going to look at name given. In fact, let's look, instead of name given, do I have, no, I have name given. We'll use that one. Okay, and let's execute this. Now, if you look down the list here, I believe you're going to find that there are some people in here that have null name givens right here. Okay, and in fact, this person has a null first name right here. Now, the problem that we're going to come across, in fact, we could probably do this with first name and last name now. Let's just get rid of name given since there's nulls in the first name I forgot about. Okay. So when I execute this, I can say where name first is null. So I'm going to get all of these guys back just to show you that there are 39 names that have no first name. Now what I want to do though is I want to produce a proper name. Okay, so I'm going to do a last name. Okay, after that I want to add into it a comma, a space, and then I want to add to it the first name. and I better come back in and put the right name in here. Name last, plus the first name, and I want to call that full name right here. Okay, from players. So I'm just going to do this right here. Just right now, I'm going to run that guy, and just to make sure it works. And notice what I end up with is I have this full name column, so Ardzima, and then David comes up as Ardzima, comma, space David. Now, the challenge with this is, though, is I expect my data to be clean, but it's not clean. I've got some major problems with my data right now. And that is that there are some names out there that have no first name. Now, here is the rule, folks, and listen carefully. Anything plus a null will always equal a null, and nulls will never be displayed. Nulls will never be displayed. So in this case, the only names that are going to come in this list right here, period, and it may be what I want, will be only those people that have a first name and a last name. If they have no first name, they're not going to show up on this list at all, and I can prove that. Watch this. If I run this statement, I'm telling it only give people to me that have first names in here, and check this out. Oops. Notice that I have no full name in here at all. It's empty. Even though it had a last name, why didn't it just put Borland over here? And the reason is a last name plus a null first name equals a null. That's going to be a problem down the road for us, because if you didn't anticipate that, you would have automatically eliminated 39 names off the bat. And a lot of times, if you have a database where you're tracking a person's first name, their last name, and their middle initial, and they don't provide a middle initial, and that's null, then all of a sudden you do a select statement. That person's name's not going to come up at all, because a first name plus a last name plus a null middle initial is going to produce a null output, and you're not going to have a full name popping up for that. Later, I'm going to show you how we can fix it, but that is going to be an issue for us to deal with. Nulls sometimes can cause major problems. Okay. So we're talking a little bit about null here. I showed you how we deal with the null. We deal with the is null or is not null, okay, depending on which we want to test for. Whereas with empty, we simply, if a balanced field is empty, then I'm going to test with 0. An empty numeric field will have a 0 in it. A null balanced field would have null in it, and it's going to produce nothing. Okay. This is an example of producing all the empty first names. But if I go back in and I run empty first name over here, where name first equals empty, these nulls are not going to show up because they're not empties. They're nulls. Okay? So null is a value in a null value in a column indicates no value at all has ever been entered, nor has there been any value to it whatsoever. Numerically, null is not a 0. It's not going to be treated numerically. If you tell it to add fields together, a null field is going to be ignored. A null field is neither larger nor smaller than a number. Although when you sort it, nulls will always sort at the top. So if you want nulls not to be included, you'll have to put a where clause in there to tell it not to include the nulls. Okay. Once a value is entered in a null field, unless it's forced, it will never become null again naturally. If I put Jones in a last name field and I go to that last name field and I delete Jones out, it's now empty. It's no longer null. Programmatically, I can force it to be null, but generally I don't want to do that. Okay. A null value is going to be excluded in any calculations later that we use except the count. And we'll talk about what count is. That's going to be in about a week and a half. And null is not a true value, but it's a state. Okay. So testing again for null, you're going to, and this is a slide where students make mistakes often. Here at the top, we're going to test for all the names. We're going to bring back all the names that are null. Here, we're going to bring back all of the name firsts that are not null. Do not use this bottom approach. If you came back in and said where name first equals null, it's going to look for the character N-U-L-L for the first name. A person who has a name null, that's not what we want. Okay, and we can't use the equal sign here. We can't say where name first equals null. We have to say is null or is not null. And again, I want to point out semicolons at the end of the statement here You'll find it in ANSI SQL, they do recommend semicolons, but in most SQL it's not required. So if you choose to put a semicolon in at the end, you can. If you don't, it doesn't matter. I believe if you go back to W3 schools, where you should be going to take a look at examples, you're going to find that they generally put a semicolon in at the end. And the last thing I want to talk a little bit about are some of the formulas that are built in. Now, before I go on, these formulas are not ANSI SQL. These are Transact SQL statements, although you're going to find that they're going to be used quite a bit. But I can use absolute things like pi, tangents, square roots, power of, if I want to. You can use it, but it's not traditionally part of ANSI SQL. At the end of this class, if there's time, we're going to come back and we're going to visit Transact SQL. When you get to your CIS 259 class, we're going to spend some more time later in Transact SQL. And later we're going to take a look at some aggregate functions. Right now we're not going to look at these aggregate functions per se, but what we'll find out is these are going to let us go back in there and pull the smallest, the shortest player out, the tallest player. What is the total sum of the salaries of a particular baseball team? How many players were born in California? Remember earlier I told you you had to look at the bottom right-hand corner of your screen in order to get your count. These statements that we're going to take a look at later, which is going to be in the next section after we talk a little bit about power use, will open our eyes up to a lot of really cool stuff that we can do in SQL. And we can also do compound statements in SQL, I want to point out. A compound statements is where we're going to use those ands and the ors. The ands and the ors work just like programming, where the innermost parentheses, so notice here in this statement I've got an outer set of parentheses here, that starting and that ending, but I've got an inner parenthesis here and an inner parenthesis here. The inner parentheses are going to be evaluated first, and then it's going to do the outer parentheses. So in this case, it's going to do the two ends here, and then when those answers come up, it's going to OR those answers together, and then at the very end, it's going to end it with supplier 127. So how does this read? Extract all parts costing more than 50 cents in California or more than 75 cents in the state of Washington that were manufactured by supplier number 127. So we have to do the ends and ors. Unfortunately, we cannot take shortcuts. We have to have complete logic on each side. So this statement you see on the bottom here will not work. Why not? Because what it's going to do is, the first thing it's going to say, give me all those the state or California, but then it's going to say or Oregon. It's going to say, what the heck does OR mean? I don't know what OR means. If I want this to work, I have to use complete logic. I'd have to say where state equals California, or state equals Oregon, or state equals Idaho. Complete logic. It's the same thing in C#. And this is talking a little bit about formulas. We've talked about formulas in the last section, derived columns, but it shows you now that I can go back into a particular column and create this derived column. Now, in this case, I'm pulling out part number, description, price times quantity, and I'm going to call that my value column from inventory. When my calling program receives it, all it knows is there's three columns: part number, description, and value. It has no idea that value was derived from price times quantity. That's hidden because, remember, only the data is being transmitted back at this point. So we can also use, as I showed you before, a formula within the where clause here. Okay. And that does present one issue I need to go back and visit in just a second here. So notice in the where clause, I'm putting in price times quantity. What I cannot do in the where clause that I can do in the order by clause is use this value. Use the value. Remember, in the order by, if I wanted to, I could go back in and order by that derived column. But when we're dealing with the where clause, we can't do that. And the reason is, as I told you before, that the order by waits for all the data to be returned. So in this case, where I've got this order by, it's going to do, on this bottom example, it's going to do all of this statement first. Okay? When it completes that statement, it will know that the value column exists at that point. Okay? So if I wanted to, I could order over here by value. But in this top example with the where clause, can't do that. And the reason is because technically the value column doesn't exist until the select statement itself is concluded before the order by clause. So in a where statement, if I try to go back in and do a where value is greater than 20, it's going to give me an error and tell me that the value column doesn't exist yet. So I have to use the price times quantity column. Let's take a look at that example again. So that's going to require me to come back over here and do a select. And let's do name last, name first. We're going to do that height divided by 12 as new height from players. See if I made a mistake here. Name last, name first, from players. Okay, now I execute that. It's going to give me back that data, and I need to do a .0 here to get my accuracy back. Okay, it's going to give me back that data. So now, I told you before that because this statement executes first before the order by, okay, then I can do an order by new height right here. In fact, it comes up in IntelliSense, and it's going to work just like that. Okay, but if I come back in here and the where clause goes between the select and the order, so if now I do a where clause and I say where new height, and notice it doesn't come back in IntelliSense even, where new height is greater than 6.0. Okay, notice right off the bat it's going to give me an error, and it says the column doesn't exist. And the reason is because this is happening at the same time. Okay, this column isn't technically created until the entire select statement is done, and then it names that column. So for this to work, I actually have to put the entire formula in here, just like that. And now it will let me get away with it. Little bit, and if you don't like that, if that's one of those things you don't want to remember, then always remember to be consistent. You always do it this way then, and you'll get the same output. Okay, same output. There is an order by, an order calculation order, if you will. The same thing in Visual Basic and C#, and that is that if you do any math in a formula, the order of calculation is multiplication, division, and modulus are first, then it does positive, negative, addition, or concatenation second, then it does your comparison operators next, then it does the nots, and then the ends, and, well, same thing I told you in Introduction to Programming, folks. Don't let this hobble you. You know, you can sit down and try to memorize this, but the best thing to do is to go back in and use parentheses and force the order to be whatever you want it to be. In this case, it doesn't matter whether this was an and or an or whatever, because it's on the inside parentheses, it's telling it to do it together, and it's the inner parentheses, it's going to do that first. So again, you can work on this, it's going to have an impact, but you can force it with parentheses. Okay, and again, this slide is going to talk a little bit about it. In this case, I've got a lot of math that's going on. I'm calculating, I've got a radius, I'm going to calculate the area of that particular, or excuse me, I'm calculating the radius. That should say area and not radius here. But nonetheless, the first thing it's going to do is this set of parentheses. Why? Well, because there's two inside parentheses, and it's going to do the left one first, but it doesn't matter, because it's going to do 22 divided by 7, come up with 3.14, and it's going to set it aside. Then it's going to do the radius times the radius, come up with an answer. It's going to set it aside. Then, because it's got another set of parentheses, it's going to do that answer times that answer, because they're in parentheses, as the third one. So the order of calculation is very important as well. And as I said before, you want to put aliases in the program. You cannot put an alias. For right now, let's keep in mind that we only want to put aliases inside of the column name, although there is a way later we're going to find out that we can put an alias on a table name. So later, what I could do is I could, oops, let me come back here, on this inventory right here, If I've got this really large statement and I don't want to have to refer to it as inventory, actually right after the from inventory I can do as I if I wanted to. And it doesn't make sense now, but in a really complicated statement we're doing joins, it might make sense a little bit later. I could do that, but I cannot put aliases in a where clause. Why would I want to do that? Doesn't make any sense. And I certainly don't want to do an alias and order by. If value is the column, then I'm going to order by value, or I'm going to order by the formula, but I'm not going to put value afterwards. That just doesn't make sense. Okay. Distinct. Let's talk real quickly about distinct. What distinct does is it says, just give me one example of that piece of data that's going to be returned. So let's go back in. The example that the slide says is, what cities or states do I do business? Or what part names have I sold over the past month? Or what streets names are represented in my table? Or what are the baseball teams in baseball, if you will? Or what are the last names that exist in my table? Whereas if there's 30 Joneses, I only want Jones to be returned once. Okay, so let's take a look at an example of that. So if I come back over here, and let's just keep this really simple here. I want to know all the birth states that players were from. So let's get rid of all of this stuff right here. So I just want to know the birth states from players. If I execute this, oops, it's not birth states, it's birth state. Okay? I execute it, and I get all the states back. But if you look down through the list here, you're going to see, look at Ohio. It's repeated multiple times. So if I just want to know what states do baseball players come from, and I only want it the list once. I don't care if Alaska is in there one time. I want it listed once. Whereas if New York's in there 50 times, I only want New York listed once. So I can use the keyword distinct here. Okay? And if I use distinct here, it's only going to list back. And notice now I've got 130 rows, and part of the reason is there's foreign countries in here. There's a lot of fat finger in here, but you'll see that everything is listed only once. And if I order this data, just to prove it, order by birth state right here, and I run it, I better only get 130 back. I still get the 130 back, but now look at they're in order. And also notice that null did sort. Even though, because it was a state, it saw and said, give me all the different elements that are in birth state. Null was one of them, even though it's not a value. It saw it there. If I don't want null, I'd have to put a where clause in here where birth state is not null, and that would have excluded that. So what ends up happening is I only end up getting that distinct birth state. But students will make mistakes with this. And let me give you an example here. Let's say that if I put a distinct star in here, I'm going to get exactly the same records back that I would get whether I had distinct or not. And the reason is it's going to say, look at that entire row of data. Is there any difference in that entire row of data over the next? If there is, list it. And every row of data has a primary key, so I'm going to get back every record. Notice 18,846 here, whereas if I didn't have distinct in here and I reran it, I get the same number back. Distinct returns back the distinct of the combined list that you're giving it. So, for example, if I do distinct birth state, let's do birth city, comma, birth state, okay, from players. Okay, if I do it that way and I check this, okay, what it's going to do is it's going to give me back every distinct birth, city, and state that exists. I'm only going to have, look, these are foreign countries here. Let's go down below here. But I'm only going to have one Ozark, Arkansas listed, period. It's not going to list multiples. Now, but what it will do, though, is watch this. So I want the birth cities of Portland. Now, check this out. Look at this. There happens to be 5 different cities where baseball players were from in the United States with the name Portland. So even though I have distinct here, why did it give me back Portland, Arkansas, and Portland, Indiana, and Portland, Maine, Portland, I think that's Ontario, Canada, or Portland, Oregon? Why did it give those back to me? Because it combined the two. It combined the two and said, well, Portland, Arkansas is different than Portland, Indiana, or Portland, Oregon, so I got those differences back. But if I had only put in, check this out, if I'd only put in city right here, I'd only gotten one Portland back, because it makes sense. So be very careful about this distinct, because it takes the entire, oops, grab something here, and Control Z, it takes the distinct of the entire list. Not just the first column, but of the entire list, because can cause some problems for us. So if we go back in, let's just show you another one. Let's pull up contributions, because that's got another example in there I can use. So I've got this table donations. Let's select, oops, and I better select the right table up here. Contributions. So I want that from table donations. There's almost 1 million records in this column, in this table, by the way, folks. Execute right here. Okay. So now, if I'd like to know, I want to know all the unique. Let's try here. The unique. I want to know all the zip codes within Spokane County. All the zip codes where donations were made from within Spokane County. So what I'm going to do here is I'm going to bring open zip, and I want the distinct zip. I don't want 299,207s to pop up. I only want one, but I want it where the state equals Washington, and I believe those are the right column names. Let's double check here. Didn't seem to give me an error right away. So I got state and I got city, and city equals Spokane. Okay. So if I execute that now, I'm just going to get those zip codes. There's 25 different zip codes, Spokane, Washington, where donations were made. Okay. And notice that I got 99201, 202, 203, 205, blah, 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 and somebody fat-fingered one, because that's certainly not a Spokane, Washington zip code right there. It probably should be 99216, I'm guessing, but I don't know, and I'm not going to correct it. That's some of the errors of the data that exists. But watch what happens if I take distinct out. Now, notice 25 rows there. Take this out, execute it. Now I've got 1,117 rows, because that's how many donations were made from Spokane, Washington. It's going to give me every zip code in here, and zip codes are going to be repeated. So I don't see right off the top. There's two, pardon me, there's two 99203s right there. So that gives you an example of what distinct does. It's a great place. It's a great command to deal with. And this explains the weakness of city, state, that the distinct is the distinct of the entire column list combined together. And we talked about white space before. White space is ignored. I can do my entire select statement as you see here. Doesn't matter if I do it that way. I could do it this way if I wanted to. I could do it this way. And if I check it, you'll find that white space is ignored. I would highly recommend you don't do that. And if I wanted to, of course, I could put everything in one row, which is going to be common, by the way. Why are you going to want to put it in one row like this? Because later, that's what you're going to pass to your program. But either way, it still runs the same way. So, folks, we pretty well have completed this lecture. We've talked about the order by clause. We've talked about the where clause. We've gone back in and we've taken a look at the distinct, trying to understand the distinct clause a little bit and how it works. So this should prepare you now to dive into a little bit more power user stuff we'll have in the next section.